Hello class, this is a video tutorial on bivariate data analysis. In this video we're going to be looking at Pearson's correlation coefficient. Pearson's correlation coefficient is a calculated value that classifies the strength and direction of a linear correlation. Just before we continue, I didn't get to write it down. The special letter that Pearson's correlation coefficient has is the letter R. So now the value of R can only go from +1 to -1. And between each, we have different strengths, strong, moderate, and weak, and the direction. Obviously, if we get a negative R value, that's a negative correlation. And if we have a positive R value, that's a positive correlation. And you can see this little table that I put here. So a value of 1 is perfect positive correlation. A value of -1 is perfect negative correlation. Between 0.75 and 0.99 is strong positive. A value between -75 to -0.99 is strong negative. And this pattern continues. You can copy this table down. But more importantly, in this video, we're going to show an example on how to do this. You can probably already see on the screen, we have a calculator ready to go because we're going to be using our statistics mode in our calculators to do this. So let's clear first. So how we do the clear is shift, clear all, and let's clear everything first. So first we need to set up into stat mode. So we're going to be using mode, stats, so number 2. And we want this number 2 here, A plus BX. That's our linear bivariate data. So we're going to click number 2. Now in the X and Y column correspond to our values here of height and mass. So X values for height, Y values for mass, M. So let's input these values in. 163, enter or equals, and mass 55. A height of 165, and then we enter a mass of 60. So I hope you're seeing the pattern that we're doing. So for all the X values, we just input these values here into the corresponding column. So we're up to 170. So 170 and mass of 64. 175, oops, 175 here, oops, and then a mass of 66. 178, 65 for the mass, 180 for the height, 180, and the mass is 70. A height of 182 with a mass of 71. 186 and 74, and last one 190 and 78. So now we should have a table that looks something like this with all the data points corresponding. Once again, X is our height, Y is our mass. Once we've input this in correctly, we just now going to go clear. So we're going to press AC. Notice how we still have the stat mode on. So now we're going to go into this menu here, stat variance, so shift or second function and 1. We have all these values here, and you can start exploring and find out the values that we want. I believe the value we want is from number 5. Number 5. Notice how there's an R value here. That is the one we are looking for. So we're going to press 3 R and you press equals. So this gives us an R value of 0.974. So in here once again, so our R value is 0.97432 and dot 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 dot. And let's just approximate this to 2 decimal places. So this gives us 0.97. And because we have an R value of 0.97, that is a strong positive correlation. So this group of data here definitely has a strong positive linear correlation. Hope that gave you an insight into using your calculator to calculate Pearson's correlation coefficient to classify the direction and strength of a scatter plot. Hope to see you in the next video. Best of luck.